If your search stack already speaks BM25, you do not need to throw it away to add semantic RAG retrieval. You'll learn how the pieces fit into a workflow that blends keyword matches with vector intent to supply grounded answers. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Search for answers in enterprise text polls against two instincts. One wants exact word-for-word matches, invoice numbers, IDs, single-line facts. The other wants intent and paraphrase, the meaning behind a user question. Hybrid search gives us both. Keep BM25 for the precise hits, add embeddings for the related meaning, and hand the generator cleaner, more grounded candidates. Think of hybrid search as asking two questions at once. Did the query use the same words? And does it point to similar meaning in embedding space? A support ticket that says billing error should match a knowledge base entry that says invoice dispute. Pure lexical search can miss that. Pure vector search can drift on exact identifiers. Hybrid retrieves the right passages for RAG by balancing both signals. We will build a small pipeline that checks the cluster, creates a hybrid index, ingests a few documents with embeddings, installs a fusion pipeline, and runs a hybrid query to inspect scores. That path mirrors production onboarding. Verify health, declare schema, add data, fuse signals, then query. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, we run a quick health check on the cluster, so later steps fail with useful logs instead of silent errors. This snippet opens a baseline OpenSearch connection and confirms the cluster. Connection drift or auth drift discovered late can derail hybrid testing, so client.ping surfaces the health state, while it still costs nothing to fix. The client object captures the endpoint we will reuse in every retrieval step, and client info pulls metadata that becomes handy when we log evaluation runs. Keeping the info result around also gives us version awareness before we try to call hybrid-only APIs. The printed ping OK flag with the cluster name tells us OpenSearch is reachable before we invest effort in index setup. Having confirmed the cluster, the next step is to declare an index that stores both text for BM25 and vectors for KNN. This code provisions a hybrid-ready OpenSearch index with BM25 and vector fields. Keyword-only schemas collapse once vector retrieval arrives, so setting index.knn immediately avoids risky migrations right before launch. The embedding mapping spells out the KNN vector dimension alongside the HNSW engine, while body remains a text field, so BM25 keeps working without extra analyzers. Packing everything into body and calling client.indices.create commits the schema in one atomic step we can reuse in automation. The print statement confirms OpenSearch acknowledged the index and shows the exact fields we fused for hybrid retrieval. Next, we need documents paired with embeddings, so we push a few example passages with aligned vectors and stable IDs. This example ingests test passages with handcrafted embeddings into OpenSearch. Teams already managing curated keyword docs worry about duplicating ingest effort, so each payload here carries both the body text and its aligned embedding. The loop through client index keeps IDs stable, which makes replays safe while avoiding bulk API boilerplate for a tiny tutorial dataset. I'm using toy embeddings purely for teaching. Production runs would stream model outputs, yet the same refresh pattern confirms OpenSearch index documents ready for hybrid queries. The printed shard success count alongside the document total shows the index refreshed cleanly and will answer search requests. With documents present, raw BM25 and vector scores still live on different scales. We need a fusion layer to make them comparable. This snippet installs an OpenSearch search pipeline to blend lexical and vector scores. Without a fusion layer, the BM25 spikes overpower normalized vector similarities. So Combo instructs the normalization processor to do min-max scaling and then average the signals. Capturing the weighting knobs in Combo lets us promote keyword exactness or semantic recall later without reshaping the processor payload. The client.transport.perform request call hits the pipeline API directly, keeping the configuration under the same authenticated session as the rest of our steps. The printed pipeline name with its weight array confirms OpenSearch now holds a reusable fusion step for hybrid queries. Finally, we run a hybrid query that keeps BM25 precision while adding KNN recall, and we inspect how the merged ranking looks. This code runs an OpenSearch hybrid query that fuses BM25 and KNN responses. Keyword-only matching would miss semantic hints in the resolver text, while vector-only retrieval forgets the explicit invoice ID. So hybrid queries keeps both perspectives. The match clause delivers lexical precision. The KNN clause reuses query vec, and passing the pipeline through params ensures our normalization processor executes. Client.search yields scored hits, and turning them into the scores list makes it obvious how weight tweaks change ordering. Increasing K boosts recall, but piles on latency because more neighbors need fusion. So 3 is a balanced teaching choice. The printed ranking shows the merged order, proving the hybrid pipeline is returning a blended candidate list ready for RAG orchestration. In a real project, this connects to a support knowledge base or invoice archive. Swap the toy embeddings for model outputs and keep IDs stable so you can trace any retrieved passage back to its source when you generate answers. Hybrid search combines lexical and vector retrieval, so you get both exact matches and semantic recall. Use it when queries need precise identifiers and broader intent at the same time, such as invoices or support tickets. Fusion matters. Wrong weights will either drown the exact match or bury the semantic hits. A practical next step is to tune BM25 K1 and B on your real support dataset, while measuring top 3 precision and NDCG. Then, adjust the pipeline weights to favor recall or precision accordingly. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.